So here's part two, which deals with the short answer responses. The first question, or series of questions, asks all about sea lions and their ability to maintain homeostasis despite external environmental conditions. And you might be saying to yourself, oh man, we never talked about sea lions. We haven't even really talked about homeostasis. But with the database questions, you need to know that all of the information to answer the questions should come from the data itself. If anything, this is a good reminder of that. So when you're attacking short answer questions, again, I want to stress the first thing that you need to realize is how many marks, or recognize as how many marks is the question worth. And then the second thing you want to think about is what is the command term asking you to do. So again, do not skip past command terms and the marks. Underline them, highlight them, do whatever you need to. Because a lot of students lost points, unfortunately, because they didn't know what the question was asking. So for this first question, everyone did really well. State the relative time the Australian fur seal spent diving while at sea. I think it was something like 45 seconds or something along those lines. However, when we moved into the second one, people really had trouble. The question asks, using the data in the bar chart, deduce which factor has the most significant effect on the relative time spent diving while at sea. So you want to do two things in this response. You want to cite the data in the chart. So here I can see that Australian fur seals and sea lions and New Zealand sea lions spend a greater time, or relative time, diving while at sea than Antarctic fur seals and California sea lions. I can also see that Australian and New Zealand pinnipeds are benthic feeders, while the sea lion from California and the seal from Antarctica forage on the surface. So I take those 2 points and I draw them together to say that the most significant cause of differences in relative time is their foraging habits. So again, point out the trends you see in relative time, point out the fact that they're either bottom feeders or surface feeders, and then tie those two ideas together. Students also struggled with this question, not this one here, but this one here. Using the data in the graph, analyze the correlation between the dive duration and the oxygen stores in the different species. And so the issue here is that first you need to recognize, is this a positive correlation, negative correlation, or is there no correlation? And to go back, you can clearly see by the best fit line that this is a positive correlation. Granted, it's not the strongest positive correlation in the world, but nevertheless it is a positive correlation. And so since it is a positive correlation, in the next part of the response, you want to talk about what that means in terms of dive duration and oxygen stores. So essentially, as dive durations increase, so does the ability of the sea lion or seal to store oxygen. Moving on, we then looked at this graph, which seemed to cause some issues for people. There are two things going on in this graph. The first is the time of dives over 2 hours and the depths of each of those dives. So you can see initially a seal, after about, I don't even know, hour and a half, dives down for a relatively short amount of time, comes up to the surface for a while, then dives down again for a bit longer time, comes up to the surface for a shorter amount of time, dives down again for slightly longer, comes up to the surface for even a shorter amount of time, and so on and so forth. So you want to identify the trends you see. And looking at this graph, I see a couple of things. Number one, the sea lion, or the seal, is diving to a shallower and shallower depth each dive. And the second thing I see is that it's spending less and less time on the surface, and it's spending slightly more time down below the water. So what I would expect is eventually this all to kind of even out, and for the seal or sea lion to recuperate on the surface. The second part of this question asks you about the temperature differences, and you can see right away that the difference between the seal's skin and the water is very great. Every time it dives down, it becomes a little less of a difference. But there is this fluctuation between when it's on the surface, warming up, and when it's down below and its body is losing heat. But you'll notice over time, it's becoming more and more difficult for the seal to warm back up again. So its body temperature is getting closer and closer to the water temperature. A lot of people said that this is the seal adapting, and that's not the case. The seal is actually losing its battle to maintain homeostasis. And so at this point, it's going to need to take a break and hang out on the shore for a while and warm up. Moving on here, explain 2 mechanisms or adaptations used in mammals. 2 good ones would be oily fur or blubber. People did pretty well on this question. And then here is where we started to have real problems. So I'm going to go over and grab my handy dandy pen. And the first thing that you need to do is to take a ruler and measure the actual length of this line right here. And when you do that, you're going to find that it's about 4 centimeters. Okay. The next thing I want to do is I want to convert that to the unit used in my scale, which is microns. And in order to do that, I'm going to have to multiply this by 10,000. So that's going to give me 40,000 microns. But I'm not quite done. In order to figure out how much this has been magnified, I need to divide it by 2, because that's the number in the scale, and that's going to give me 20,000 times magnification. If you didn't get that, don't feel too bad, because only one person got it correct. So that's definitely something we're going to revisit here. Scrolling down, the second question asks for the actual diameter of the nucleus as marked on the electron micrograph. This one's a little easier. You essentially just have to figure out how many of these can fit across this line. And it's essentially about 4. So 4 times 2 is 8 microns. 8 microns. Fairly straightforward stuff. All right, this question was very difficult. Originally it was 2 marks, but I changed it to 4. There seemed to be a lot of confusion about the significance of surface area to volume ratio. And it's basically this. Cells have to be small in order to function. Because as they get bigger, their volume growth outpaces the growth of their surface area. And that decreases their surface area to volume ratio, making it more difficult for them to get the substances they need in and get rid of the waste they don't. So that's why cells, instead of getting very big, create identical copies of themselves and gather together in tissue, all performing the same function. All right, moving on. Now, these questions dealt with higher order genetic stuff, higher level genetic stuff that SL students were not responsible for, so I did not count these against SL students. But essentially, this pedigree is autosomal recessive inheritance. Autosomal recessive inheritance. That's what we're looking at here. And so if you knew that, you did pretty darn well. Moving on to the sex-linked problem. A lot of people struggled with sex-linked problems as well. So you got to remember that hemophilia is an X-linked recessive disorder. In this case, our husband doesn't have it, but our wife is a carrier. So she also doesn't have it, but she carries it. So if you were to do this cross, you would find out that just their son has a 50-50 chance of getting hemophilia. All right. Option D was fairly straightforward. Did pretty well here. Everyone seemed to understand this graph and everyone seemed to do a very good job of answering these questions as well. We learned a lot of issues there. The one question we did stumble upon was describe how carbon-14 can be used to eliminate the age of the fossil. The problem that people had was carbon-14 doesn't decay into carbon-12, it decays into nitrogen. One of its protons becomes a neutron, and thereby it's balanced as nitrogen. And that caused a lot of confusion for people. This question was very difficult, and I understand why. But polyploidy is this idea that sometimes, with plants especially, the chromosomes don't separate the way they should. And so you can get plants that have 3 sets of chromosomes or 4 sets of chromosomes. And since plants can reproduce with each other, or excuse me, with themselves, suddenly you can get entire new populations of plants within another breeding population. This is, I believe, sympatric speciation. I always get those two mixed up. And then last but not least, we have the essay. And again, most folks did pretty darn well on the essay. So here's your second secret question. If you can respond to me with your favorite color, I will send you your score. So again, you need to provide the answer from the first video as well as the answer from this video here, what's your favorite color. If you reply with both of those answers, I will send you your test score.